Today we're going to be talking about simplifying radical expressions. And what you can do when you simplify a radical expression is you can combine two different radicals, as long as the index or the root that you're taking is the same. You can combine those radicals under one radical. Meaning, when we have the square root of 2 times the square root of 8, I can multiply those together under one radical and get 16 and simplify that to 4. And same thing with any of our roots, as long as those roots are the same. So our first example is similar to what we did in the previous lesson. Just here, we're going to have something left over underneath the radical. So square root, let's break this down. 25 is 5 squared. I need to break this down into powers of 2 because our root is 2. So a to the 4th, a squared, squared. Now b to the 9th, that's not even, so it doesn't break down evenly into a perfect 2 power. But b to the 9th can be broken down into b to the 4th squared. Say b to the 4th squared, that gets me b to the 8th. I have b to the 9th underneath my radical, so I have a b left over. So this then I can pull out the 5, I pull out the a squared, and I can pull out the b to the 4th. Now, I've taken care of this term, I've taken care of this term, I've taken care of this term. I have a b here left over underneath my radical, so that stays inside the radical. Simplifying something to the 3rd root. Very similar. Like we were doing in the last lesson, put everything to the 3rd power. So 125 is 5 to the 3rd power. M to the 30th. I need to put this to the 3rd power, but these need to multiply to be 30, and there is a perfect number, 10, 10 that multiplies to be 30. Now p to the 20th. Okay, think about it this way. 3 goes into 20 6 times. So what I have there is p to the 18th. What's left over? P squared. Because I would have p to the 18th here with this term. I need to get to p to the 20th, so 18 plus 2 would get me to 20. Now simplify this out. 5 to the 3rd, that just comes out as 5. The root 3 and this 3 cancel, so I'm left with m to the 10th. P to the 6th and to the 3rd, that simplifies to p to the 6th. And I'm left over with that cube root, don't forget that cube root, of p squared.
So in this example, we need to simplify where we have two radicals where we're going to be multiplying them together. So take the 5 and just leave that outside. And now we're looking at the cube root of a few things. 100 times 10 is 1,000. Then I have an a squared times an a, that's going to get me a to the 3rd power. Now write each one of these to the 3rd power. So 1,000 becomes 10 to the 3rd. A cubed is a cubed, or a to the 3rd power. So then we have 5. This 10 cubed can break out of our radical and just become a 10. The a cubed can break out of the radical and just become an a. So that simplifies to 50a. In this example, we have to multiply our radicals together. And in order to multiply the radicals together, this index needs to be the same. So I have 4 for each of them. Anything that's outside the radical, you can just multiply that like we normally do. Now we have a 4th root of a bunch of stuff inside. multiply each of the common things together. So the 8 times the 2 can become a 16. Multiply together the x to the 5th, x to the 4th, that becomes x to the 9th. And the y to the 3rd and the y to the 3rd, we add the exponents. Same base, when you're multiplying, you could add the exponents. So we get that. Now write everything to the 4th power. Or sometimes I like to break it down into powers of 4. 16 can be broken down into 2 times 2 times 2 times 2, or we can look at that as 2 to the 4th power, because the 4 and the 4 are going to need to cancel. Now the x to the 9th. Break this down into powers of 4. So x to the 4th times by x to the 4th times by another x. Because when I add those exponents, 4 plus 4 plus 1 has to equal 9. So really here, I have, actually let's just leave it like that. I lied. We're not going to do like I really have. Actually, let's just erase all that down there. I'm sorry if you wrote that down. And now let's look at our y to the 6th. Y to the 6th, write it as powers of 4. So y to the 4th times by y squared, because when I add the 4 and the 2, they're going to add up to be 6. I picked 4 because my index was 4. Now, like I was saying, this is really 2 to the 4th. So that 2 can be pulled out of our radical and just become a regular old 2. The x's. I have 2x to the 4ths. So when I multiply those outside, that's really x squared. Underneath my radical, I have this x to the 1st left over, because I can only pull out up to my radical number, or my index, I should say. Y to the 4th can be pulled out and become just regular old y. I have a y squared still left over underneath my radical. There's one thing that a lot of people forget. Remember, when the index is even and you simplify to an odd power, we're going to need to put absolute value signs over that y. So our final answer would be 6 times 2, which is 12, x squared, the absolute value of y, even root, simplifying to an odd exponent, times the 4th root of x y squared. And that ends up being our final answer.
Okay, our next example. These radicals all need to be the same number underneath the radical in order to combine them. So the first one, the biggest perfect square that goes into 45 is 9 times 5. Now for 80, when we simplify 80, we have 16 times 5. When we simplify 20, we would have 4 times 5. Now the 9 can pull out and become a 3. So I would have 3 times 3, that's 9, root 5, minus 16 would come out and be a 2, would come out and be a 4. I apologize, a 4. 4 times 5 is 20, root 5. 4 would be a 2 when I pull it out. 2 times 4 is an 8, root 5. Now combining like terms, remember your radicals need to be the same thing if you want to combine them. So those radicals are all the same thing. So I would simplify that to be equal to negative 3 root 5. Today we're going to be talking about quotient properties of radicals and how we're going to simplify radicals when we have a fraction underneath our radical. Now, something that you need to realize is a radical can be simplified on the top and bottom, so that radical can be moved to the top and the bottom. And so therefore, you can also go the other way. I can make this radical here the square root of 27 over 3, which would simplify to be equal to 9, or simplify to be 3. Same thing here. I can simplify the radical. I can move my radical on the top and the bottom. The top simplifies to squared. The bottom is going to simplify to 2, so you simplify. Now, in both of these cases, we had a perfect square. We were able to simplify, so I didn't have radicals in the bottom. But this down here is super important. Please make sure you write this down. If your radical is just a perfect square root on the bottom, and you guys should remember this from Algebra 1 and geometry, when you have a radical in the bottom, you multiply the top and bottom by that radical, and that simplifies because you'd have underneath here, you'd have the square root of 9. So that simplifies. But what if your radical was something other than 2? Something like a third, okay? What happens here is we need, on the bottom, we need to get rid of that radical. We need 2 to the third. Here I only have 2 to the first power. Okay, I only have 2 to the first power. So I need to multiply by 2 squared. So I basically have there the cube root of 2 times the cube root of 2 again. Because when I combine those under one radical, you would have the cubed root of 2 to the third, which then simplifies to be 2. And remember, we need to multiply the same thing on the top and the bottom. That's why this 2 squared over here becomes 4. Okay, so let's do some examples involving these. Okay, simplifying our expressions. First, what I want you guys to do is first simplify any perfect squares you could pull out of that radical. Meaning, we have the square root of y to the 8th on top, and we have the square root of x to the 7th on the bottom. That simplifies to y to the 4th squared, because I multiply those exponents to get me back to 8. Now x to the 7th. Since 7 is an even number, 2 doesn't go into 7 evenly, I'm going to have leftovers. So I'm going to have x to the 6th times by x, which then that simplifies to x to the 3rd squared times by x. So then on the top, those cancel, the square root and the squared cancel, and I just end up with y to the 4th over, I have x to the 3rd, and then I have this root x that's still left over. Now we don't like radicals in the bottom, so now we need to simplify that radical. We need to multiply by root x over root x, because then I would have x squared on the bottom underneath my radical. So again, underneath the radical, we would have the square root of x squared. We know that that can then, the top is remaining the same, we know that that can then turn into x, so I would have x to the 4th. Okay, our next example. Now I have something to the third root. So what we have is we have the cubed root of 2, and I have the cubed root of 9x. Now, the challenging thing for you guys is going to be try and put that 9 to a certain power. Meaning try and put it to the highest power you can. Meaning we know 9 is 3 squared. To basically clear that root in the bottom, okay, we need to have 3 to the 3rd power underneath there. So I need to have 3 to the 3rd power. How do I get another 3 to the 3rd power? I just multiply by another 3, because then I can combine those to get 3 to the 3rd power. I have to do the same thing on the top and the bottom. This x here, this needs to be x to the 3rd power. I only have 1, so I need to add in another 2. So that, let's just worry about the bottom right now. So worrying about the bottom, 3 squared times a 3, that's 3 to the 3rd power. X times x squared, that's x to the 3rd power. Okay, so then just worrying about the denominator right now, that's going to simplify to 3x. Now worrying about the top. Since this root is the same, I can combine the 2 and the 3 to get me the cube root of 6 x squared. There's no perfect cubes that I can pull out because 6 doesn't really have any powers to it. You can't break down 6 anymore into smaller powers, so we're left with 6x squared is our answer. So this whole thing here would be our final answer. Okay, multiplying radicals. Basically, this is just FOIL. Okay, just think about it like FOIL. First terms together. We would get the 2 times that 3 would be a 6 root 3. The outer terms together, you would have a minus a 2 times a root 9. Your inner terms together, 3 times 3, that would be a 9 on the outside, root 5 still on the inside, and then your last terms together, we would have a minus 3 root 15. Now simplify any radicals that we can. 6 root 3, there's no perfect squares that I can pull out. Square root of 9 is 3, so I can do 2 times 3, which would get me 6. 9 root 5, there's no perfect squares I can pull out of the 5. And the root 15 is just 3 times 5. There's no perfect squares I can pull out of there. So we're left with that as our answer. And that's okay. There's nothing I can combine. Even though 3 times 5 would get me 15, we can't combine because the radicals are not the same. Okay, simplifying with radicals in the denominator. Here I have square roots in the denominator. And we've actually done this before. We did this back when we were working with I. Okay, because I was really a square root. So when we deal with this, we do the square root of 6 minus the square root of 2. Remember, it was that conjugate. Because let's look at that denominator. Let's FOIL out that denominator. Let me show you guys. First terms together, we get 6. Outer terms together. Inner terms together. Last terms together. Those radicals cancel. That's super important. So then I'll FOIL out the top here in a minute. I just wanted to show you guys that when you FOIL it out, you're going to get no radicals on the bottom. Okay, now let's FOIL out the top. First terms together. The outer terms together, root 6 times root 2 is a negative root 12. Inner terms together. And then your last terms together, we would get a plus 2. So I can combine the 6 and the 2 to get me 12. No, not 12. 6 times 2 is 12. You want to add. 6 plus 2 is 8. Here I would add negative 2 root 12 because I have 2 root 12s that I can combine together. Simplify this root 12. Root 12 can be broken down into 4 times 3, so that would be 2 times root 4 times 3. The 4 can become a 2 outside, so that's why I have a 4. 2 times 2 is 4. Root 3 all over 4. Now remember, to simplify this, the same number needs to be factored out of all the numbers. Or write it like this. Eight over 4 simplifies to be 2. 4 over 4 simplifies to be 1. Root 3.